Hey guys, it's Miss Kurtzman. Welcome to your first screencast for the year. Since I'm not here today, I'm going to go ahead and give you a video lesson for the first lesson of Unit 3. So we're going to start our first unit, our first lesson of Unit 3, which is all about proving triangles to be congruent. So in the content library, you should have a blank note sheet that is titled SSS and SAS. So if you just follow along with this screencast, the notes are going to be filled in as I go along with the video. So after the video, you can go back and try to fill in your notes on your own, or you can copy the completed notes as well into your notebook. So we're going to go ahead and get started. So let's just review again what we know about congruent triangles. Right? So triangles are congruent when all corresponding sides and interior angles are congruent. The triangles will have the same shape and size. Right? So that was our definition of congruent a long time ago when we talked about congruent segments. Okay? So if we look at these two triangles and I drag, right, if I drag that orange dot anywhere, or if it moves around the screen, alright, our triangles are going to be congruent no matter what, right? The angles are going to be congruent, the sides are going to be congruent. PQR, right, is congruent to LMN. I could name a congruent statement, okay? So the first two ways that are we going to be able to prove that triangles are congruent, notice we have a bunch of different ways, 5 main ways. The first two that we're going to talk about today, or learn today, are side, 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 and side angle side. Okay, so I'm going to go ahead and click on this one. We're going to talk about side, 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 and I think this is the easiest one. All right, the definition of this: triangles are congruent if all 3 sides in one triangle are congruent to the corresponding sides in the other. Right? If I know that's true, then our triangles have to be congruent. Okay, so this was very similar to what we saw a second ago. If our sides are congruent, then angles P, Q, and R are going to be congruent to the corresponding angles in L, M, N. Right? No matter how I move these triangles around, as long as the sides are congruent, then the corresponding angles will be congruent, so the triangles will have to be congruent. Okay, so if we go back to our note sheet, we can start filling in some notes for today. Okay, so let's go ahead, make sure I have my marker. All right, so SSS, right, we now know this stands for side, side, side. The first way to prove that triangles are congruent. So if 3 sides of one triangle are congruent to the corresponding sides of another triangle, then the triangles are congruent. Okay. So my first example here is ABC congruent to DBC. So looking at what I've marked already in our 2 triangles, I'm seeing 2 pairs of congruent tick marks. We see that AB is congruent to, over here, if I said AB, I would need to say DB, right? Noticing the first 2 letters of how I've named the triangles. And I also have marked that AC is congruent to, well, if I said AC, I would need to say DC. Okay? But I don't see a 3rd pair of congruent segments. But if we think about BC is a part of both of these triangles. So we're going to be doing this a lot in this unit. I could draw these triangles separately. I could pull apart ABC, so BC was standing alone, and then I could pull apart DBC, so again that BC was by itself. I could remark our triangles what we originally had, and now we know that BC has to be congruent to BC in each of those 2 triangles, because BC would be congruent to itself. So in the end, we would know that triangle ABC is congruent to triangle DBC by side, side, side. All right, we can just use SSS. So if we look at some more examples here, right, I said state whether the side, side, side could be used to show that each pair of triangles are congruent. Well, if I look at these two triangles right here, I'm seeing one tick mark, I'm seeing the 3 tick marks, 3 tick marks, 2 tick marks, 2 tick marks. If all those sides are congruent and I have 3 pairs of congruent segments that are congruent, then yes, these are congruent by side, 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 right? Over here, if we think about what we just practiced, or what I just illustrated for you with triangle ABC and DBC, this segment is being shared by both of those triangles. So again, I could pull them apart, or I know that I could go back and I could mark 1, 2, 3 tick marks on the diagonal that that rectangle has, and that the segment that both of those triangles are sharing. So yes, again, by side, side, side. If we look at our last pair of triangles over here, I'm only seeing 2 pairs of congruent tick marks. I am seeing the red angles, or the red angle markings right here, right? But I'm not seeing a third pair of congruent segments. So right now, we would need to say no by side, 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 but we will learn later in a couple of minutes that these may or may not be congruent by another way to prove triangles to be congruent. Okay. So we're going to go ahead, or I'm going to go ahead and draw some triangles off to the right here, right? So just to review corresponding parts of congruent triangles. So if I had triangle A, B, C, and then over here I had triangle W, C, L, and I indicated that AC was congruent to WC, AB was congruent to WL, and then over here I put 2 tick marks. My first question, AB, again, we would know that needs to be corresponding to WL. Right? Angle A would need to be corresponding between the first tick, the one with 1 tick mark and 3 tick marks. That needs to be corresponding with angle W. Right? Why is ABC congruent to WLC? Well, if we think about what we were just talking about, yes, by side, side, side. Okay. If measure of angle A is 65 degrees, then what other angle is 65 degrees? Well, we said if those were corresponding, and we just said our triangles were congruent, well, each of those would be 65 degrees. Angle W, the measure of angle W, is also 65 degrees. Okay, so the second way that we can prove triangles to be congruent, we're going to go back to our website over here, is side, angle, side. So this picture, these triangles are showing, right, if I look at the bolded blue segments, that if I have 2 segments, right, in 2 triangles that are congruent, and I have the included angles in both of those 2 triangles, then we will always know that our triangles are congruent, right? So no matter how our triangles are moving around, or no matter how much, or how I'm extending P, Q, and L, M, right, that third side of our triangle will always have to be the same length. And that means that R and N will also be congruent, and then our other 2 angles, P and Q, would be then congruent to L and M. Okay. So again, if I move them all around, right, as long as my included angle is between my congruent sides, PR and RQ and LN and M, then our triangles will be congruent. So you can read that there. The third sides are also equal, PQ and LM. the remaining two corresponding angles are equal. Alright, so if we go back to our notes, alright, SAS, this stands for side, angle, side. Alright, so if two sides and the included, that's the important word, angle of one triangle are congruent, to the corresponding sides and the angle of another triangle, then the triangles are congruent. So which pairs of triangles are congruent by side, angle, side? Well, we think about what we were doing up at the top. I could mark those two sides to be congruent and I could practice pulling them apart, but I don't have the included side. These two angles are located outside of our congruent sides. So I cannot use side, angle, side to prove those to be congruent. However, in these triangles, I do have the included side. So these triangles will be congruent by side, angle, side. And then last but not least, this is also an example of the angles being included between the two congruent pairs of segments. So yes, by side, angle, side. And then the last thing that we're going to talk about down here is the additional segments that we would need in order to prove triangles to be congruent. So for example, if I wanted to use side, side, side to prove RST to be congruent to YZX, right? I would, or suppose I wanted to use, and I said I have TS and I have XZ, and then I said YZ and RS. Well, the additional statement that I would need, and if I'm looking back to how I had named RST and YZX, well, we would then need to say RT needs to be congruent to YX, making sure that I'm naming them in the correct order. So if I stick with those congruent tick marks, right, and then I said, and I have TS and I have RS, and now I want to be, and I have XZ and YZ, and I want to be using side, angle, side. Well, now we need the included angle. So the included angle between TS and RS would be angle S. And down here, the included angle between XZ and YZ would be angle Z. We would need to know that angle S is congruent to angle Z. Okay? And I could mark that. Okay? Say, for example, maybe I changed my mind and I decided that I wanted to then go with TR and XY to show another example to use SAS, right? Then I would need to be using angle R and angle Y. So this would be a second example of using SAS, but I would just need an additional or a different pair of angles to use side, angle, side. So tonight's homework is going to look similar to what we've been doing or what I've been showing you on today's screencast. All right. It's this worksheet that should be also in the content library. So you're going to be practicing or showing whether or not you can use side, side, side or side, angle, side to prove that the triangles are congruent. And then on the back, you're going to state what additional information is required in order to know that the triangles for the triangles are congruent for the given reason. So what I was just doing at the end of our notes there. So if I want to use side, 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 what other segments do I need to be congruent? Or if I want to use side, angle, side, do I need a pair of angles or do I need another pair of sides to enclose that included angle? Alright guys.